Hello all. In the case study in the engineering chemistry, we're going to study about the corrosion failures. There is case studies of corrosion failures in the structures. So what is a corrosion? Corrosion is a disintegration or a decomposition of materials. It may be either a natural process or chemically an induced process. So the corrosions are many types. So it may be wet corrosion or a dry corrosion. The corrosion may be due to hydrogen, the corrosion may be due to oxygen, the corrosion may be due to some salt solutions such as electrolytes. So these corrosion obviously affect the materials, particularly the civil structures. So the problem of corrosion of a steel embedded in concretes and deterioration of this concrete possesses a major threats. So the bridges, the buildings, all are made up of some steel materials. So these steel materials, they undergo corrosion after some time because when they expose to an aggressive environment, so this environment sometimes may aggravate or increase the rate of corrosion. So there have been many of corrosion failures in a very short period, in few months, in few years. Due to the corrosion, the structures may undergo a failure. Some long-term failures may also arise. So these corrosions have been appeared in many countries. We can discuss it by case approach. So from the late 1960, the case 1 will discuss this. The structure is post-tensioned concrete bridge, length of 500 meter, pre-stressing steel of diameter 26 mm and tensile strength of 1018 Newton millimeter cube was used. In this bridge in Germany, after 9 years of the services, the structure developed numerous longitudinal and diagonal cracks in different locations of the bridge. So after later investigation in 77-78, it was revealed with an additional failures too. It is found that the grade of mortar injection in the ducts of a pre-stressing members are not sufficient and adversely affected the properties of steel. Grouting was found imperfect. So these imperfectness created some longitudinal and diagonal problems, damages. So a poorly grounded portions showed a severe pitting and a uniform corrosion. It was extensively corroded. This was influenced by and it was aggregated by humid environment developed around the pre-stressing steel. Accelerated corrosion metallographic examination shows that the cracks in the pre-stressing steel upon 400 millimeter resulting probably due to the microclimatic conditions. So after this, the bridge has been demolished and rebuilt in 1980. So within a span of 20 years, this bridge life has been collapsed because of its poor grouting. So another case, Thane Creek Bridge in Mumbai. It is a post-tension bridge across Thane. It had 1,836 meters. The bridge consists of 40 spans and 240 girders. It was thrown upon to service in 1972. In 12 years it was thrown upon. What is the corrosion problem here? It was an adverse longitudinal crack was been observed for 8 to 10 years, within the span of 8 to 10 years of service because of corrosion in the material structures. The problem is the exposure of the cables to the aggressive marine and industrial environment. So usually the marine and industrial environment have some adverse effects because the marine water acts as an electrolyte which can aggregate or increase the corrosion level. So under ununiform and imperfect grouting, absence of any protective coating on exposed bottoms and sides of the girders. So these things played a major role in destructing this particular case, Thane Creek Bridge. And the third case we discuss is about Florida, USA. A segmental bridge in USA, Florida district, constructed in 1979, used an epoxy coated rebar. The concrete cover provides was a 10 centimeter and a low water cement ratio of 0.40 was being used. But the problem is the first concrete spalling was observed in 86. See, within 7 years of life, the concrete spalling was after 10 years of construction. Several corrosion was observed on the epoxy coated bars. So the metal up to 1 millimeter has been consumed. Mechanical damages of a coated rebars during the handling and concreting under film corrosion at the bend. Several weathering occurs, mainly the high chloride content at the rebar depth because it is near the marine structure. So 2.5% is the weight of the cement. We have these effects, adverse effects. So the main reason of the corrosion is epoxy coated rebars. That plays a major failure in the structure. Then in the case of Kuwait, it is a telecommunication training building was constructed in 1972. Showed a deterioration of concrete and corrosion of steel reinforcement in foundations. The 4 meter below the ground level, which led to an intensive cracking settlements and tilting of the wall by 1 inch, 1 degree, outside in 10 years after construction. There is no 1 degree tilting of this huge building. The corrosion problem is steel bars from the slab was crumbling and disintegrating columns were severely cracked. Sizes of the cracks in the slab was 10 mm. This deterioration is a result of a sulfate attack in the soil. The soil contains a huge amount of sulfate. These sulfate deteriorate these materials and made a huge impact, or about 4 meter below the foundation level, and made the huge building tilted towards 1 degree. So if we go for a case 5 in Chicago, a reinforced concrete column and balconies of a high-rise housing complex of 28-story building was built in 1961. So the corrosion problem is severe cracking and spalling of concrete was observed. Several corrosions of reinforcing bars embedded in columns and balconies occurred in 12 and 20 floors in 10 years after construction. So, after 10 years of lifespan, they observed the concrete, the huge building with 28 housing, the reinforced bars embedded in the columns have been get corroded. So this particularly due to the surrounding humid condition was not taken into account by the builders. When you go for a case 6 of Bahrain, the structure is a form store reinforcement concrete framed structure in Bahrain. Was located 3 kilometers from the sea, constructed in 77, and the premature deterioration was observed within a lifespan of 10 to 15 years of the construction. The structure consists of columns and beams with 100 millimeter thickness scale slag. So the corrosion problem, most of the exterior columns, beams, mainly the balcony beam was cracked. The cracks were observed parallel to the main reinforcement in both columns and beams. Roof beams and balcony beams were cracked. The cover of the concrete varied from 30 to 50 millimeters. So in case 7, we go for a navally fertilizer plant in India, Tamil Nadu. The RCC roof slab and prilling over tower urea bagging station, exposed chemical environment showed area growth and concrete surfaces in 5 years after construction. The height of the prilling tower structure is 55 meters. The corrosion problem is due to the spraying of a urea solution. Particularly, the urea solution was about 99% concentration into the prilling chambers. The penetration of urea into the building leads to deterioration and spalling of concrete due to a severe corrosion and embedded steels. The rebars with 10 mm have been reduced to 6 mm within 5 years after construction. The urea sprayed was giving a major impact on the structure. So the conclusion part. So what is a corrosion? We say that a corrosion is a dry or a wet process. It may be an oxidation process, it may not be an oxidation process. The corrosion will be influenced with some climatic conditions, even the climate, temperature around the system, and the materials presence in the soil can also place a major impact over the corrosion. The buildings near the seashores get easily corroded because of an influential effect of the sea. The salt water or the moisture containing the salt will be acting as an electrolyte which will influence the corrosion more. So this has been observed in Bahrain. So in the Bahrain, it was a major thing. So in Chicago, due to the humid condition, we faced some lot of structural damages. In the Kuwait also, the sulfate which is present in the soil makes the deterioration, that is, the sulfate things are corroding the structures. So, corrosion, when we considering the corrosion, corrosion may not be influenced by a simple one factor. It is a combination of multiple factors. So the multiple factors has to be taken into account so that the corrosion things should be avoided. So in the cases we studied about around 7 structures. These structures has been collapsed within a span of 10 years. So we can imagine that how the corrosion rates affects. So in the conclusion part, we can say that many structures, when the adverse environment, have experienced an unacceptable loss in the severity or safety for an earlier than anticipated due to the corrosion of reinforcing steels and thus need replacement, rehabilitation, or repair. So the many structures, as we see now, has been corroded or been affected, damaged, mainly because of the environments. Having experienced unacceptable loss, so safety of the structure has to be considered. These structures have been to be rehabilitated or should be replaced. So after these kind of cases, the overall assessment of the atmosphere, soil, and other things of chemicals which is present in the soil, as we see in Kuwait, the sulfate played a major role. So that has to be analyzed. It's the major part. So it can be seen that corrosion of reinforcing steel is proven to be a global problem. Yes, steel easily get corroded. Yes. So in the steel, the percentage actually, it's the steel is not only corroded by the oxygen, the presence of moisture. Okay, the presence of moisture is also playing a major role. So that in the steel, the carbon percentage has been nowadays increased. So to make the strength. So to avoid corrosion, the chromium percentage are also to be maintained. In an ordinary iron, easily get corroded with the absence of chromium. So another suggestion may be given that to increase to decrease the corrosion effect. So we can also add a chromium with this, so that the chromium is an anti-corrodic material, so which can provide some resistive effect to the materials to avoid corrosion. Carbon is usually added to increase the strength, so the carbon percentage may not be changed. It is around 2% or 3% like. So the chromium or nickel percentage can be added a little bit, so that we can manage the corrosion tendency of the steel. So we should understand the inhibiting behavior of the corrosion inhibitors. Yes, the corrosion inhibitors are the chemicals or things which we add to the material while putting the concrete or while putting the wall. We have to add a corrosion inhibitors. These inhibitors cover the surface of the material, and which does not allow the corrosive chemicals or oxidative elements to get into the material. Sometimes when the inhibitors are not efficient, or in a particular place the inhibitors are not properly covered, those areas starts corroding. So we should understand that inhibiting behavior of the corrosion inhibitor against the steel corrosion is an alkaline chloride solution and its effect on different concrete materials. So we have to study about the alkaline chloride solutions. So the alkaline chloride solution, even the inhibitors present, it can be affecting some problem. So we have to study with this alkaline chloride solution so that we improve the property of an corrosion inhibitor. With the improvement in the property of corrosion inhibitors, we can improve the strength of the containers, strength of the concrete. So, in this study, particularly, the study is intends to stress the importance of the meeting or the requirement of a structural engineering and electrochemical requirements together for achieving a better corrosion control measures for a steel reinforcement boss. So, we lay an intent to stress the importance of meeting the requirements of a structural engineering. So, and electrochemical requirements, that is, the requirements which has to be satisfied to avoid the corrosion things, and we achieve a better control measures for steel reinforcement boss. So go for the reference like Romanian SAD Association GP and GP and Pepinar of Comparativa Institute Constellator. So this thing has to be referred to understand the collapse of these structures. Thank you. We'll meet in probably the next case today.